Do you wonder what is the best method for learning and, more importantly, retaining the coding knowledge? Do you find that as you go through tutorials, reading books, that is nearly impossible to retain such a large amount of information? In this episode, I will try to explain the best learning process and will give you several methods to retain what you learned. Let's first look into how brain learns. Before beginning, I should mention that many ideas that I am about to share come from the book A Mind for Numbers. You should definitely check it out. People repeat a subject over and over to learn it, so their minds gain fluency on that subject. That is the illusion of learning. In fact, they try in vain. They don't learn anything. Just like the labor of the one who tries in the vain to lift the timber he stands on, he gets tired but can't achieve anything. There's no point in repeating the knowledge by the person who is trying to create a new way of thinking in the mind. Accomplishing something causes liking it, and loving it gives the opportunity to spend more effort. More efforts results in more success. This is positive feedback. Therefore, after taking the first steps and starting to love something, it becomes easier to put in the effort. Success follows. So you need to create a lot of small programs in order to feel accomplishment, or you can commit to a big project but celebrate every small success. The human brain has two different ways of thinking: deep, focused thinking, and scattered thinking. These two modes cannot exist simultaneously in the brain. As soon as we focus, we inhibit the disorganized mode of thinking. In focused thinking, the brain tries to solve the problem in an algorithmic way, implements the protocol has already been learned. Multiplying numbers, tackling a social situation like giving a presentation is done in focused mode. It helps us to think about an idea more easily. The prefrontal cortex, the area just behind the forehead, is responsible for this mode. Neurons close to each other fire simultaneously and at the same frequency. It's a great case for a problem you know the solution to. Scattered mode, on the other hand, can happen while walking, jogging, doing a physical activity, or even just resting. Whatever you taught in the previous focused mode, your brain is now fully working on that subject, not just the prefrontal cortex. An algorithmic solution may not be obtained in this mode, but it can be ensured that the neurons connect with neurons that they do not usually work with. Thus, new understanding and solutions are gained. No solution can be found in this mode, but a solution can be approached. When learning a new subject, it is necessary to alternate between focused and diffuse modes. Focused mode prepares the brain, diffuse mode enables different neurons to connect, giving new insights, synthesizing with the previous known ones. Then the focused mode algorithmically implements a new solution path along with the new understanding. As a result, the subject is learned by working together of the two modes. Humans has three types of memory: working, temporary, and permanent. When we try to remember a phone number, the number is in your working memory. It needs energy to stay in our minds. We forget as soon as we stop trying to retain it. Working memory can hold up to four different pieces of information at the same time. When we understand the subject we are focusing on, the information is transferred to the temporary memory. Knowledge is also doomed to be forgotten here. However, if we try to remember the information we have acquired for a few days at intervals of a few hours, it becomes permanent memory. Programming concepts take up a lot of working memory at first, but once they grasp, the compression is very high. Now the whole concept can be kept in mind as a piece of information. Permanent memory is like an endless repository. It is therefore normal for chunks of information to be lost. If we want to access information whenever we want, we should make this information easy to access with the spaced repetition method. The key is to try to code, so you try hard to remember what you learned. Another secret to success in programming is to build lots of stacks. What is a stack? It is a collection of chunks of information, just like a zip file. While studying the subject, many information and concepts are encountered. A stack is formed by bringing together this information in a semantic integrity. At first, while learning is taking place, the temporary compartments of the brain are all filled. Neurons are connected to each other like a tangled pathways, rather than by a direct path. Therefore, initial learning is difficult. However, when learning takes place and understanding is achieved, this subject fills only one temporary compartment in the brain, and by holding the end of it like a rope, access to all information about that subject can be easily achieved without going into wrong directions. An example of this is that people learning programming may have very different opinions about a subject at first. They may come up with strange ways of understanding that would baffle a programmer. Those may actually make sense, but they are paths that go to wrong way within that subject. Learning happens in two ways. Building a stack is learning from the bottom up. Grasping the context is learning from the bottom down. Grasping context is seeing the big picture. If stacks are parts of the puzzle, context is the whole picture. Finally, retaining practice should be done again during the same day and should be done again in a few consecutive days. First of all, critical reading should be done and the information should be learned. After reading once, it is repeated. Repeating too many times should be avoided as it will create a learning error. Then the learned information should be tried to be remembered after the access to the source is closed. Real learning takes place while trying to remember. By repeating this a few times, a step is taken towards understanding. After comprehension has taken place, stacking is supported by spaced repetition. It should not be overlooked that time is needed for this. That's why it's important to do programming projects. You must remember the information you have learned. This reinforces learning. Meaning, as soon as you understand something about programming, try to code about it, and you should continue using that concept for the upcoming several days. Don't be tempted to look at the source. Try hard to remember what you learned. When you're reading or watching programming related material, you're just learning how the right way of doing things is. But you need to learn hundreds of the wrong way of doing things to understand the topic at hand truly. And you need to build knowledge stacks which you can refer to. As I told you just before, the only method of learning that many knowledge is just trying to apply what you learn by actually programming and doing this consistently. One way of doing a lot of actual programming is building a project that is related to you. But you may ask, how can I find project idea? Let me give an example from myself. When I first started programming, I tried to code the Mario game from the scratch. This has been incredibly useful for me. I learned a lot about variables, control flow, loops, functions, and even image formats. My algorithmic thinking has improved. I started to read and understand other people's codes. Of course, this is not something that will happen right away. It's going to take time. The nice thing about game programming is that you can see an output at every step, so you will get positive feedback and start to love, and the more you love, the more effort you will put. If you also want to learn programming by creating a game, you can find the Programming by Gaming guide via the link in the description. Thanks for listening.